So hello and welcome back to the lecture series. आज के इस वीडियो लेक्चर में we will look at practice set 1.4. This practice set is actually very easy. In this you will have a simultaneous equation. It will be given to you, but that equation will be a non-linear equation. So first you will learn how to convert a non-linear equation into linear equation, and then you will find the solutions by using methods which you have already learned. For example, elimination method, substitution method, graphical method, or Cramer's rule. So I hope you enjoyed this video. So without any further delay, we'll start with the lecture. So for practice set 1.4, I have taken an example from your textbook page number 16 where you have this table in which there are three columns. First is equation, the second is number of variables, and the third is check whether the equation is linear or not. So as I said earlier, in this particular practice set, you will have some non-linear equations. In non-linear equations को हम convert करेंगे into linear equations and then we will find the solution using any method जो आपने 1.1, 1.2 और 1.3 में सीखा है. For example, by using elimination method, substitution method, graphical method या फिर Cramer's rule. So before moving on to that, let us discuss this. If you observe the first equation is 3 upon x minus 4 upon y is equal to 8. Now if you observe the number of variable is 2, it is already given to you. Now it will, whether it is a linear equation or not, you can determine this by using this. If you remember the standard form for any linear equation, the standard form was ax plus by plus c is equal to 0. In this, if you observe the variables variable x and y, they are not in the denominator, they are in the numerator position. But if you observe this example, 3 upon x can be written as 3 multiplied with 1 upon x, but this is not the standard form. Linear equations do not have such format, so we can say that this is not a linear equation. Moving on to the next equation that is given to you, it is 6 upon x minus 1 plus 3 upon y minus 2 is equal to 0. Again, this equation can be written as 6 multiplied with 1 upon x minus 1 plus 3 multiplied with 1 upon y minus 2 is equal to 0. Again, if you compare this with the standard form, it is not in the standard form. Linear equations can only be represented in this format. So again, I can say that the number of variable in this example is again 2, but this is not a linear equation. Now we don't have to discuss for the third and fourth equation. Of course, you can say the number of variable in both the cases is 2, but they do not represent a linear equation in two variables. I hope this is clear to you. Now we'll just look at how to convert a non-linear equation into linear equation. I'll take two examples from the given examples. I'll copy the first equation, that is 3 upon x minus 4 upon y is equal to 8. Now in this particular equation, I can write this equation as 3 multiplied with 1 upon x minus 4 multiplied with 1 upon y is equal to 8. Of course, we can write this. In this particular example, if I put 1 upon x as m and 1 upon y as n, then what will happen to the equation? The equation will be modified. Instead of 1 upon x, I will write m, and instead of 1 upon y, I will write n. So the equation will be 3m minus 4n is equal to 8. If you want, you can shift this constant on the left hand side. So the equation will be 3m minus 4n minus 8 is equal to 0. So now if you observe this, this is an equation which has two variables m and n, and the power of both the variable is 1. So I can say that this equation is linear equation in two variable. If you want, you can compare this with the standard form. So what I have done is, I have converted a non-linear equation into linear equation by substituting the given variables. But the thing is, if you solve the equation, you will get the value of m and n. So if you want to find the solution, what you will do, using the value of m and n, you will find the values of x and values of y. We'll look into this in the later part. Before moving on with the exercise, I'll take the another example. If you observe the second example in this table, it is 6 upon x minus 1 plus 3 upon y minus 2 is equal to 0. Fine. The same equation can be written as 6 multiplied with 1 upon x minus 1 plus 3 multiplied with 1 upon y minus 2 is equal to 0. Of course, I can write this. In this particular equation, I will put, if I write 1 upon x minus 1 as m, and if I put 1 upon y minus 2 as n, then this equation will be transformed into this format. 6m plus 3n is equal to 0. So again, if you observe this, this is a linear equation which has two variables m and n, and the power is 1. So I can say that this represents a linear equation in two variables. If you want, you can compare this. Achha, one more thing, in this particular example there is no constant, so I can say that uh, if you want, you can write this equation as 6m plus 3n plus 0 is equal to 0, because there is no constant, so constant can be taken as 0. So I hope this is clear to you. We'll look into the example without wasting much time. Fine, so we'll start with the practice set 1.4 question number 1, which says solve the following simultaneous equations. If you observe this, these are not linear equations because they are not in the standard form. So what we need to do is, before solving this, we will convert the given simultaneous equation into linear equation. Before starting with the solution, I'll just copy the equations. 2 upon x minus, wait, I'll write this again. The equations are 2 upon x minus 3 upon y is equal to 15, and the second equation is 8 upon x plus 5 upon y is equal to 77. Now in both the equations, if you observe this, I can write the equations as 2 multiplied with 1 upon x minus 3 multiplied with 1 upon y is equal to 5, and the second equation can be written as 8 multiplied with 1 upon x plus 5 multiplied with 1 upon y is equal to 77. Of course, we can write the equations in this format. So to convert this equation into linear equation, what we will do is, we will substitute, we will put 1 upon x as, let's say, m, and 1 upon y as n. So what will happen to the equations? The equations will be transformed. The first equation will be written as 2m minus 3n is equal to 5. I mark this equation as 1. What about the second equation? Look at this. This will be transformed as 8m plus 5n is equal to 77. I mark this equation as equation 2. Now if you observe them, both the equations are linear equation because they have two variables and the power is 1. So now I can easily solve this using any method. Elimination method ho sakta hai, graphical method, Cramer's rule, it's up to you. So for now I'll go with elimination method. So now we have equation 1 and 2. To solve this, I will use elimination method. In this, what I can do is, if you observe the coefficients of variable m, in the first equation it is 2 and in the second equation it is 8. So I'll try to make them same. So for this, what I can do is, I can multiply, if I multiply equation number 1 by 4, so the equation will be 8m minus 12n is equal to 20. I mark this as equation number 3. What I have done is, simply मैंने equation 1 को multiply किया with 4 और equation 2 को we have not changed. So now 8m minus 12n is equal to 60. Wait, here it was 60. This was the equation number 3, and equation number 2 will be copied as it is. 8m plus 5n is equal to 77. This was equation number 2. Now if you observe the coefficients of variable m, in both the case it is same. So I will subtract the equation. So what happens when we subtract? We change the sign. Plus 8m will be minus 8m, plus 5n will be minus 5, and plus 77 will act as minus 77. So if you solve this, 8m minus 8m will cancel each other. Minus 12n minus 5n will give you the value as minus 17n is equal to. Now 60 minus 77 will give you the value as minus 17. So n is equal to minus 17 upon minus 17. So this will cancel and the value of n turns out to be 1. Now using this I can easily find the value of variable m. So if I put n is equal to 1 in, let's say, in equation 3. So equation 3, I'll just copy it. Equation 3 was 8m minus 12n is equal to 60. In this I will put n as 1. So this will be 8 into m minus 12 multiplied with 1 is equal to 60. So this will be 8m minus 12 is equal to 60. So 8m will become 72. Minus 12 को shift करेंगे on the other side. So this will be 60 plus 12. So m will be 72 divided by 8, which will turn out to be 9. Therefore, I can say the value of m is 9. I'll just continue on this side. The value of n turns out to be 1 and the value of m turns out to be 9. But if you read the question once again, the equations that were given to you were having two variables x and y. We have the value of variable m and n. So we need to find the values of x and y. So if you observe this, look at this statement. We have already written, let 1 upon x be m and 1 upon y be n. So what we will do is, in this equation we will put the values of n and m. So this will be 1 upon x is equal to m ki jagah I will write 9 and 1 upon y is equal to n ki jagah pe you will write 1. So just multiply this, or will not multiply this, just shift the places. So this will be 1 upon 9 is equal to x and y is equal to 1 upon 1, which means 1 itself. So y is equal to 1. So now I have the values of x and y. So I can say the required solution is x is equal to 1 upon 9 and y is equal to 1. I hope this method is clear to you. Moving on to the next sum. If you look at this, again you have two equations, but these are not linear equation in two variables. So first we will just copy the equations. First equation is 10 upon x plus y plus 2 upon x minus y is equal to 4, and the second equation is 15 upon x plus y minus 5 upon x minus y is equal to minus 2. So now first step is we need to convert this into linear equation in two variable. The same equation can be written as 10 multiplied with 1 upon x plus y plus 2 multiplied with, I'll just erase this. The second equation can be written as 2 multiplied with 1 upon x minus y is equal to 4, and the second equation can be written as 15 multiplied with 1 upon x plus y minus 5 multiplied with 1 upon x minus y is equal to minus 2. So now in both the cases, if you observe this, I can say, if I put 1 upon x plus y as u and 1 upon x minus y as v, the equations will be modified. After substituting the values of 1 upon x plus y and 1 upon x minus y, the equations will be 10u plus 2v is equal to 4. I mark this equation as, let's say, equation number 3, or we'll take it as 1, and the second equation will be 15u minus 5v is equal to minus 2. Let this be equation number 2. So now if you observe this, the equations have been transformed into linear equation in two variables. So to solve this, again I'll use elimination method, but you are free to use any method. If you want, you can go with graphical method, Kramer's rule, or substitution method. For now I'll go with elimination method. So I need to eliminate any one of the variable. To make the required changes, what I can do is, I'll consider the second variable for now, that is v. If I multiply equation 1 by 5, and equation 2 by 2. The equations will be transformed. The first equation will be multiplied with 5 and the second equation will be multiplied with 2. So the equations will be 10 into 5 will be 50u plus 2 into 5 will give me 10v is equal to 20. I mark this as equation number 3 and the second equation is multiplied with 2. So 15 into 2 will give me 30u minus 5 into 2 will be 10v is equal to minus 2 into 2 is minus 4. I mark this equation as equation number 4. Let this be equation number 4. So if you observe this second variable ka coefficient is now same. So if the signs are opposite, we will add the equations. Plus 10 minus 10 we will cancel this, cancel the term. 50 plus 30u will be 80u is equal to 20 minus 4 will give me 16. So u is equal to 16 divided by 80, which will give you the value as 1 upon 5. I hope this is clear to you. So I'll just write this again. The value of u turns out to be 1 upon 5. After this, I can easily find the value of the second variable, that is v. What I will do is, if I put u is equal to 1 upon 5 in, let's say, in equation 1. So the equation 1 was 10u plus 2v is equal to 4. Replace u with 1 upon 5. So 10 multiplied with 1 upon 5 plus 2v is equal to 4. So this equation will be 5 into 1, 5 into 2 is 10. So this will be 2 plus 2v is equal to 4. Shift this 2 on the other side. So this will be 2v is equal to 4 minus 2. So 2v is equal to 2, v is equal to 1. So now I have the values of u and v. I'll just write this again. The value of u was 1 upon 5 and the value of v is 1. But now if you look at the question once again, the variables that were given to you was x and y. So we need to find the values of x and y. So how to do this? If you observe this, we have taken u as 1 upon x plus y and v as x minus y. So we will return the value of this variable. Now how to do this? Back to this step. We know u is equal to 1 plus x plus y and v is equal to 1 upon x minus y. We have already done this. I'll just put the value of u as 1 upon 5 and the value of v as 1. So the equation will be 1 upon 5 is equal to 1 upon x plus y and 1 is equal to 1 upon x minus y. So if you take the reciprocal of this equation, then you will get x plus y is equal to 5 and x minus y is equal to 1. So now I take this equation as equation number 4 and I mark this equation as equation number 5. So again I have two equations which are linear equation in two variable. I can easily solve them. The first equation was x plus y is equal to 5 and the second equation is x minus y is equal to 1. So now in this case, if you look at the second variable, that is y, the coefficient is same. So I will add the equations. Plus y minus y will get cancelled. X plus x is 2x and 5 plus 1 will give you the value of 6. So x turns out to be 6 divided by 2, that is 3. So the value of x is 3. Now I need to find the value of y. So for this, what I will do is, this was equation number 5 and this was equation number 4 and this was equation number 5. Put x is equal to 3 in equation 5. So equation 5 was x minus y is equal to 1. X is 3 minus y is equal to 1. So this means minus y को shift करेंगे on the other side and 1 को on the left hand side. So this will be 3 minus y is 1 is equal to y. So y turns out to be 2. After this, you just need to write a final step. The required solution is x is equal to 3 and y is equal to 2. I hope these solutions are clear to you. Moving on to the next sum. If you observe this, again you have two equations which are not linear equations. So we will convert them into linear equations. So for this particular question, I will directly start with the solution. If I put 1 upon x minus 2 as m, and 1 upon y plus 3 as n. So the equations will be transformed into this format. 27m plus 31n is equal to 85, which I mark as 1, and the second equation will be transformed as 31 into m plus 27 into n is equal to 89. I mark this equation as 2. So the equations have been converted into linear equation in two variable. I hope this step is clear to you. We have already done two questions of the same type. Now, to solve this particular equation, what we can do is, if you try to make the coefficients of any one of the variable same, so what will happen, even if you multiply it with some number, the calculation will be much difficult for you. So if you remember practice at 1.1, we had such questions in which the numbers are greater as compared to other questions. So in this, what we do, we go with two separate methods. In the first case, we add the equations, and in the second step we subtract the equations. By doing this, we get two more equations which are comparatively simpler and convenient for us to solve. So just look at this. In the first place, I will add the equations. So what will happen? 27 plus 31. If you add 27 plus 31, this will give you the value as 58m, plus 31 plus 27 will give you 58n is equal to 85 plus 89 will be, if you calculate this, this will be 174. Again, if you want, you can simplify this, because if you look at this, m and n ka coefficient is same. If you divide this equation by 58, so the equation will be m plus n is equal to, if I divide 174 by 58, so this will be 174 divided by 58. This turns out to be m plus n is equal to 3. Yes, this is the new equation. Again, now look at this before moving on. If you compare equation 1, equation 2 with this, solving this equation, that is equation number 3, is much more convenient than solving the given equation. So that is why we will go with this method. First, I will add the equations, and I will obtain an equation. After that, we will subtract the equations. Again, we will get some other equation which will be much more convenient for us to solve. So now, without wasting time, in the second place, I will subtract the equations. So if you subtract the equations, so what will happen now? 27m plus 31n is equal to 85, minus 31m plus 27n is equal to 89. Again, if you remember, if you subtract, signs will change. So 27 minus 31, so this will give me the value as minus 4m. 31 minus 27 will be plus 4n, and this will be minus 4. Again, this equation can be divided by 4. If I divide this by 4, the equation will be minus m plus n is equal to minus 1. I hope this is clear to you. I mark this equation as equation number 4. Now consider equation 3 and equation 4. I'll copy the equations. Equation 3 was m plus n is equal to 3, and fourth equation is minus m plus n is equal to minus 1. So if you observe this, the coefficient, the variable m, the coefficient of m is 1 in the first equation in this, and in the second place the coefficient is minus. So I'll directly add the equations. So plus m minus 1 will get cancelled, minus m will get cancelled, and plus n will give me the value as 2n, and 3 minus 1 will give you the value as 2. So n turns out to be 1. I now have the value of n. Using this, I can easily find the value of m. Put n is equal to 1 in equation 3. So what will happen to this? In equation number 3, I'll just copy the equation. Equation 3 was m plus n is equal to 3. N will be taken as 1 is equal to 3. Shift this one on the other side. So m will be 3 minus 1, that is 2. So m turns out to be 2. Now we have the values of variable m and n. I'll just copy them. M is 2 and n is 1. But we need to find the values of x and y. The variables that were given to us was x and y. So look at this, जो हमने already consider किया था. We take m as 1 upon x minus 2 and n as 1 upon y plus 3. So we'll just return the values. M was 1 upon x minus 2 and n was, let me just look at this once again. This is 1 upon y plus 3. Fine. Now it is very easy for us to calculate this. M is 2 is equal to 1 upon x minus 2 and n is 1 is equal to y plus 3. Now just multiply them on the other side. So this will be 2x minus 4 is equal to 1 and this will be y plus 3 is equal to 1. I'll just solve them separately, simultaneously, side by side. So this will be 2x is equal to, if I shift this minus 4 on the other side, so this will be 1 plus 4, that is 5. X turns out to be 5 by 2. X turns out to be 5 by 2. And in this case, y will be, if I shift 3 on the other side, so this will be 1 minus 3, which is minus 2. So the required solution is, x is equal to 5 by 2 and y is equal to minus 2. I hope these solutions are clear to you. Now we'll move on to the next sum. That is the last sum of this practice set 1.4, which is again same, but it might be a bit lengthy, but we'll just do it. Before solving this, just observe the equations. The first thing is 1 upon 3x plus y and the second term is 1 upon 3x minus y. If you look at the second equation, again this term is repeated, 2x plus 3y, 3x minus y. So easily you can say, if you put 1 upon 3x plus y as, let's say, a, and 1 upon 3x minus y as b, the equations will be transformed. Using this substitution, I can easily say the first equation will be converted or modified in this format: a plus b is equal to 3 upon 4. Let this be equation number 1. If you observe this, there is no, I don't think it is difficult, because 1 upon 3x plus y, it is taken as a. So I have just replaced 1 upon 3x plus y as with a, and 1 upon 3x minus a is replaced with b. If you look at the second equation ko, if you look at this, you can write this as 1 upon 2 multiplied with 1 upon 3x plus y minus 1 upon 2 multiplied with 1 upon 3x minus y is equal to minus 1 upon 8. So in this whole term will be taken as a and this whole term will be taken as b. So the equation will be 1 upon 2a minus 1 upon 2b is equal to minus 1 upon 8. I mark this equation as 2. But before using these equations, we can still modify them. In the first equation on the right hand side, the constant is 3 upon 4. So to get rid of this fraction, what we can do is we can multiply the equation by 4, and even equation 2 can be simplified. So if you multiply the equation 1 by 4, so the equation will be 4a plus 4b is equal to 3. Let this be equation number 3, and we'll just again write this equation, or we'll solve this separately. This is a by 2 minus b by 2 is equal to minus 1 upon 8. This is b. So the denominators are same, so I can write a minus b upon 2 is equal to minus 1 upon 8. So 2 into 1, 2 into 4. So the equation now is a minus b is equal to minus 1 upon 4. So this equation after simplification can be written as a minus b is equal to minus 1 upon 4. I mark this equation as 4. Or if you want, again, this is again same as equation 1. We have the constant as a fraction. So to get rid of fraction, again I can multiply this with 4. So we'll go with that method again. It will make things easier for us. I hope this is clear to you. If I multiply equation 4 again by 4, the equation will be 4a minus 4b is equal to minus 4. Let this be your equation number 4, not this. So to solve, I will copy the equations. Equation 3 was 4a plus 4b is equal to 3. This was equation number 3, and last equation is 4a minus 4b is equal to minus 1. This was equation number 4. Now to solve this, if you observe the second variable, that is b, coefficients are same, 4 and 4. So the signs are opposite. So easily I can say I will just add the equations. Plus 4 minus 4b will cancel. 4 plus 4 will give me 8a is equal to 3 plus minus 1. So this will be 2. So a is equal to 2 upon 8, which is 1 upon 4. So this implies a is 1 upon 4. So now I have the value of the first variable, that is a, which turns out to be 1 upon 4. Now to find the value of b, it is very easy. If I put a is equal to 1 upon 4 in, let's say, equation 3, I'll copy the equation 3, 4a plus 4b is equal to 3. 4 multiplied with 1 upon 4, a has been replaced with 1 upon 4, plus 4b is equal to 3. 4 and 4 will get cancelled, so the equation is 1 plus 4b is equal to 3. Shift this one on the other side, so this will be 4b is equal to 3 minus 1. 4b is equal to 2, so b is equal to 2 by 4, which will turn out to be 1 upon 2. I hope this is clear to you. Uh, Now we have the values of a and b. I just copy them once again on this side. A ka value is 1 upon 4 and b is 1 upon 2. But initially, if you observe the question, the variables were x and y. We now have the values of a and b, so we need to return the values of the variable. So for this, look at this, the substitution is important. We took a as 1 upon 3x plus y and b as 1 upon 3x minus y. So we'll just copy them. Fine. Now a was taken as 1 upon 3x plus y and b was taken as 1 upon 3x minus y. A ka value is 1 upon 4 is equal to 1 upon 3x plus y, and b is 1 upon 2 is equal to, not 3, the value of b was 1 upon 3x minus y. Just take the reciprocal on both the cases. So 3x plus y is equal to 4. This is the first equation. Let this be equation number 5. And this will be 3x minus y is equal to 2. Let this be equation number 6. Now again, if you observe, you have two more equations in two variable. You can solve this using any method. So I'll go with elimination method for now. If you want, you can use Cramer's rule or graphical method. I'll copy the equations. First is 3x plus y is equal to 4, equation number 5 here. And this is 3x minus y is equal to 2, which is equation number 6. So if you observe the second variable y, if I add the equations, y plus minus y will get cancelled. 3 plus 3x will give me 6x is equal to 4 plus 2 is 6. So x turns out to be 1. The value of x is 1. Easily I can find the value of y. If I put x as 1 in, let's say, in equation 6, I'll copy the equation 6, that is 3x minus y is equal to 2. Put x as 1, so 3 into 1 minus y is equal to 2. Shift this 2 on the left hand side and shift this minus y on the right hand side. So this will be 3 minus 2 is equal to plus y. 3 minus 2 is 1, so y ka value turns out to be 1. Just write a final statement. The required solution is x is equal to 1 and y is equal to 1. So this was all about practice set 1.4, in which you had nonlinear equations. We have looked at how to convert a nonlinear equation into linear equation, and the method is same. If they are asking you to find the solution, it is nothing but finding the value of x and y. So I hope this is clear to you. In the next video lecture, we will look at 1.5. Till then, thank you, and we'll meet in the next lecture.